right, page 218 in your textbooks. I want to start by looking at some review stuff that, just make sure we don't forget some of the stuff from the beginning of chapter 4. Obviously, all of this has already been tested, but you'll see it again at the end of the semester, or end of the quarter on your exam. I guess you'll see it at the end of the semester as well, but more immediately at the end of the quarter. 1 through 11. The odd also did 34, 36, and 38 on on page 209, I believe it was. And then back on the previous, there's those. Good. Excellent. And bueno. All right. Number 1, there on page 218 of the review section, it says convert to slope-intercept form, identify the slope and the y-intercept. What was your equation, first of all, Kendall?
Y equals -3/4 x plus 3.
All right, let's take a look here. We had a 3x negative 4y equals 12. And if I want to get the y by itself, walk me through. What did you do?
You have the 3x as negative.
And here's what I think happened, Kendall. I think this negative disappeared. So I think you divided everything by 4 instead of dividing everything by negative 4, because your signs were all exactly backwards. And that makes sense. So do you see you should have had a positive 3/4 x and then a negative 3. So your slope should have been
3/4.
And your y-intercept should have been 0, negative 3. Number 3, you're supposed to find slope-intercept form of the line given 2 points. First of all, you had to find the slope. Maddie, what was the slope on number 3? Good. We should have found our slope to be negative 9/10. And then we're going to take that slope and either one of the 2 points, Genesis, pick one. The negative 12, 4, slightly smaller numbers. That's the point I would have chosen as well. And we should have taken this, and to find the equation, I need to write out. And we just plug in the numbers. So in for the y,
4.
In for the m, in for the x, and I'm going to put that negative 12 class over 1 so I can see a little bit of canceling, plus the b. 12 and 10, by the way, can cancel to get me anyone? 6 and 5. Also, I've got 2 negatives, class. That cancels to get a positive, so I end up with what right here, back to Genesis?
54.
Yeah, 4 is equal to a positive 54/5 plus b. I sure do hate that big fraction there. What might I do to knock it out?
Divide everything by the LCD.
Well, multiply everything by the LCD. I multiply everything by 5. I could have gotten to 20 is equal to 54 plus 5b. Could have subtracted away the 54, anyone, to get? Negative 34 equal to the 5b. And that would have gotten me a b value of negative 34/5. The other option is on your calculator. Simply do 4 minus 54/5. Your calculator will give you negative 6 and 4/5 instead of negative 34/5. That's okay, I guess. Anyway, our equation should have been, when it was all said and done, y equals the negative 9/10 x and then the minus 34/5. How many had that? For number 3. Okay, just a few of you. Questions from those who did not. Or again, if you had negative 6 and 4/5, that would have been correct also. All right, any questions, comments? Good job on that one. Michael, number 5. Are those lines parallel, perpendicular, or neither? You said?
Neither.
Why?
Because they are not parallel or perpendicular.
Why not?
Because they don't have similar slopes or negative reciprocal slopes.
Good, they don't have the same slopes, nor do they have negative reciprocal slopes. So they meet neither of the criteria for being parallel or perpendicular. Therefore, all they do is intersect very boringly. Number 7. Want the equation of a line that passes through 5 or negative 5, 1 and is parallel to the given line. Again, parallel meaning, Audrey?
Same.
So for number 7, the line they gave us has a slope of
4.
So that's also going to be the slope of my line. My line, however, goes through the point negative 5, 1. We presume the line they gave us probably does not. We're going to do the same kind of thing. Write out
Y equals mx plus 3.
There we go. And plug in the
1
equals.
4 times negative 5 plus 3.
And we'll end up with a b value of
21.
21. So I got the m, I've got the b. What's the equation?
Y equals 4x. plus 20.
And there we go. Again, it did say in standard form, we don't do that, but if you wanted to, I guess 4x minus y equals negative 21. But I like that better. Number 9, find the equation of a line passes through 3, 8, and is perpendicular to the given line. Again, perpendicular meaning what, Brandon?
Negative is above the slope.
So the slope of the line they gave us in number 9 is
Negative 5/4.
negative 5/4. Therefore, my slope has to be
4/5.
positive 4/5. Again, going through the point 3, 8. And again, we'll start with the y equals mx plus b. Plug in.
A equals 4/5 x times 3 plus b. Then I multiply the 3 and the 4 to get 12 over 5.
Mm-hmm.
I don't know what I think I did on the calculator. But
Okay.
I got 28/5. Well, you move it over as a negative. And 12/5.
Good, move it over as a negative, and you end up making this a 40/5 if you wanted to. You know, 8 over 1, 40 over 5, subtract away 12/5, you get 28/5. That's another way you could approach it. You could multiply everything by 5, you just do it on the calculator. End up with 28/5 or 5 and 3/5 for your b, and so the equation
Is y equals 4/5 x plus 28/5.
and there we go. How many have that answer for number 9? Questions on number 9? And number 11, find the constant of direct variation for the table of values. We know it's direct variation, not inverse variation, because inverse variation of a constant product. And we don't. We get 20, we get 0, we get 16/5, we get 80. So obviously it's not inverse variation, it's direct. What are we constantly multiplying by to get the y value, Abby?
4/5.
We keep taking 4/5 of the top number, 4/5 of negative 5, 4/5 of 0, 4/5 of 2, 4/5 of 4, 4/5 of 10. So our equation then is y equals 4/5 x. How many had that for number 11? All right, questions on that part of the homework? All right, well, let's go and review what we started talking about in our last lesson, and that was a special type of function in which the x is squared. Special type of function in which the x is squared, and that's the highest power of x that we'll have in our function. We're talking about what type of functions, Maddie? Quadratic functions. I said the general form of a quadratic function is going to be what, Kendall?
Ax squared plus bx plus c.
Good. F of x equals ax squared plus bx plus c. That's our basic look to a quadratic function. We said a quadratic function, when you graph it, unlike a linear function, which is a straight line, the quadratic function is going to be what? Genesis? Michael? When I graph a quadratic function, what shape do I get? You get a parabola, remember? And we said a parabola can look like either a or upside down. You kind of more, I guess, an N, you might say. But either, what is it that makes the difference here, Genesis? Okay, this point here is called the vertex, and I guess it's whether the vertex is at the bottom or whether the vertex is at the top. But what about the equation or the function itself will tell me which way my function is positioned, which way my parabola is positioned?
A and B.
Audrey?
Yeah, positive and negative.
For which?
For the you have a positive.
What's positive?
The A.
The A. Okay, so if A is positive, then we have this look, and of course here that would be if the
A is negative.
A is negative, okay, and that'll determine whether the parabola is going up or down. Now, remember, back when we first talked about domain and range of functions, we said that a quadratic function is going to limit the range. And we said it's either going to be vertex to infinity or negative infinity up to vertex, one of the two. But I had to give you the vertex. Well, no longer. You can find the vertex yourself. How do I find the vertex of a parabola? Abby?
First you just factor out the A,
Okay.
and then you take negative 1/2 of the B.
Good. Take negative half of B after you've factored out or divided out the A. Now, a lot of times we won't have to worry about the dividing out the A, so negative half of B is sufficient. That gives me the x value. How do I find the f of x value, Brandon?
Whatever the negative f, yeah, that, whatever that is, you put it into that f.
Yeah, take f of that. And once you've taken f of all of that, that'll give you the other part. And that's what you were doing on the rest of the homework, numbers 34, 36, 38. Flip back to page 209. Flip back to page 209. And number 34, 36, 38, you were finding the vertex. They gave us the function of x is x squared minus 4x plus 7. And here, conveniently, we don't have to factor out the a, do we? So all I'm going to do is take negative half of b to figure the x value. What is that x value then, class? Positive 2, right? Negative half of negative 4 is going to be a positive 2. And then when we find f of 2, we end up getting what here, Michael?
I blanked out. Hold on.
F of 2?
Oh wait, yeah. 3.
3. 4 minus 8 plus 7 is a 3. So 2, 3 must be the vertex. We said if we wanted to, and you didn't have to do this for the homework, but if we wanted to graph, we could set up an x and f of x table of values. And of course, we know the vertex 2, 3 would be your first point. From there, we said because of the symmetry of the parabola, the way that it goes up the same on both sides as it spreads outward, we could find two values at once. So for my next x, I'd actually do 2 at a time. What two x values are going to share an f of x value, class? 1 and 3. Remember we said go one smaller and one bigger, and both 1 and 3 will share the same f of x value. So I think 1's the easier value, so I'm going to say, well, what's f of 1, class?
Wait, I'm at
4. So 1, 4, and 3, 4 are my next 2 points that I could graph. I could find another pair of x's that are going to share the same y. 0 and 4, of course, the easier one here is going to be f of 0, and that's going to give me a 7. So 0, 7, 4, 7 would be a couple of points there. And then if I want to do one more level, I like to do 3 pairs along with the vertex. We could use negative 1 and 5. Which one do we want to use? Okay, Abby is not intimidated by the negative. So Abby, f of negative 1. 12 is correct there. And I want you to notice something interesting. Gap of 1, gap of 3, gap of 5. There's a pattern even in that as we work here. So if I wanted to graph it, and for now I'll just show a quick sketch graph. We'll do detailed graphs later. But we could plot our vertex at 2, 3, and then in a sense, class, you're going to go over 1, up 1. Then you're going to go over 1, up 3. And then over 1, up 5. And then if you were to keep going, which we don't want to, over 1, up, what do you think? 7. Then over 1 up, 9. That gets you that basic parabolic shape that something-ish like that. And it always looks better over a graph paper than it does that way. But we get the idea. Do you remember going over this in our last lesson? And we had a weekend since then. Questions? All right. Number 36. This time, what did I have to do first that I hadn't really had to do up to this point? Genesis? I'm sorry? Yeah, I've got an a value, so I got to do what with that a? Pull it all out. So we're going to factor out that a value right up front. Factor out the 4 to get and now to find the vertex, now that we've pulled out the a, now I can simply take, well, negative half of the b, which negative half of the b value would be a negative 3. And then to find the corresponding y value, or f of x value, class, simply find f of negative 3. And hopefully you use your calculator to do this. And you found it to be, class, I'm getting negative 16 also. Let's see if that's what the book likes. Yeah, they like that one. How many get negative 3, negative 16 for your vertex? All right, questions.
I just forgot to multiply it by 4. I had negative 4. That's what I had.
Oh, you instead of, okay, so what you did was you took the negative 3. I just went back to the original. You came back here. Gotcha. Okay, yeah, save yourself the trouble. Go back to the original when you plug it in, and that'll make your life easier. All right, and it'll help you avoid mistakes at least. All right, let's take a look at number 38, where we had f of x is a negative 2x squared, positive 4x, negative 10. And again, anytime there's an a value, what do I have to do with it first, Brandon?
Factor it
What is the a value I'm factoring out here?
in.
It is a negative 2 that's being factored out. So, we pull out a negative 2. What am I left with?
X squared negative 2x and then positive 5.
All right, so for my vertex, now that I've pulled out the a, I need to take
Negative half of b.
negative half of b, which is now a
1.
positive 1. Of course, go back to the original would be my recommendation. Take f of 1, and we end up with
Negative 8.
negative 8. How many had? 1 negative 8. Anyone have 1 negative 4? Or 1 positive 4, perhaps? All right, again, if you go back to the original, that keeps you from making that mistake. What direction is this parabola going to go, class? Downward, right? It'll go downward instead of upward if we took the time to graph it, which we won't. Questions on that? All right, I want you to do 33, 35, 37. Use that vertex formula, negative half b after you've pulled out the a. sake of time, let's go ahead and take a look at these together. On the first one, we go to find the vertex. Nice thing is, we ain't got to factor nothing. We just take negative half of b, Maddie, and then we find f of negative 1 to get what, Kendall? Negative 10. And so my vertex is negative 1, negative 10. How many have that for number 33? All right, questions? On the next one, unfortunately, what do we have to do this time, Michael?
Take out the 3.
Take out the 3, and when we factor it out, it's going to give us what?
X squared, 2x, 4 and 2/3.
Or I'm just going to leave the 14/3. The weird thing is, it's 14/3. Who cares? All you're really keying in on now is this b value. Because for the vertex, you have to take negative half of that, which is
Negative 1.
negative 1. And again, as long as you don't come back to where it's weird to plug in the negative 1, as long as you go back up here to the original and take f of negative 1 here, it's not too bad, Michael.
11.
Yes, yeah. And so negative 1, 11. How many have that for number 35? Again, just another advantage of not going back to the weird one. All right, then for the last one, what do we have to do first here, Audrey?
Take out negative 4.
To get?
X squared positive 6x. Negative 6x.
Good. It's going to be a negative 6, and that is going to make a difference here in a moment.
And positive 6.5. Or 13.
Yeah, or positive 13 halves, whatever. All right, all that really matters, though, is keying in on this negative 6, right? Because for my vertex, I'm going to have to take negative half of that, 3, and then I've got to find f of 3, Brandon, to get...
154.
I don't think so. Because 3 squared is 9 times negative 4 is negative 36. That's a negative 62. I'm adding a 72 to that for f of 3, so I'm going to 10. Yeah. 310 for our vertex. Yeah, the book likes that too. All right, so let's go with 310 for the vertex. How many have that on 37? Questions on 37? Yes, sir.
So, do you have to factor out, like, the a? Because I did not factor out them without thinking, and I still got the same answers.
Right, ultimately what matters is it comes out here, correct? Because what I end up doing with this, all I really care about is that b value, right? It just has to come out of that. For instance, if you didn't pull it out, you just took negative half. Well, that's going to give you a negative 3. That's not right. It's a negative 1, right? So we do at least have to get the b value out of this part.
Yeah, but I just took the negative half out of the 6, and then I just divided it by the 3.
Which is the same thing,
Okay.
right? You could divide by the 3 at first, then take negative half. You can take negative half, then divide by 3. It's the same
Okay.
thing. Yep, good question. All right, any other questions on that? All right. Now, because, though, that this trail number, this constant at the end, doesn't always divide that well, you really could get away with only worrying about the beginning part. And if you did, we get to what's called the standard parabolic form of the quadratic. The general form, as we already have in our notes, is the ax squared plus bx plus c, right? That's what we're used to seeing. But next thing in your notes, the standard parabolic form of a quadratic function looks a little bit different. Write this down if you would. F of x is equal to a times x minus h squared plus k. This is yet another way in which you could find the vertex. It's a little bit of a different approach. But where we're going to end up going with this, it's going to give us a lot of additional information about our quadratic. So we're going to begin looking at ways that we can use this form, as opposed to the general form, the more common form, to graph a parabola more readily. Now today we're not going to really get into how do you graph it. Today we're simply going to go with how do you find the vertex. And you do need to know that in this form, the vertex is hk. K here simply stands for constant, even though constant is spelled with a C. K stands for constant, kind of like it did with the constant of direct variation, the constant of inverse variation. The H means something else that I'll explain later. When you're ready. For now, it just seems like a really random letter to choose. Okay, but the vertex is at HK. I do want you to notice the negative sign. That's important. If I gave you this quadratic, f of x is equal to 2 times x minus 3 squared plus 5, for instance, I can tell just by looking at this quadratic where the vertex is. This is in the form x minus h, where h is a 3 and k is a 5. The vertex is 3, 5. I can tell just by looking. Okay, if I gave you the function of x is negative 7x plus 1 squared minus 3. Well, here I can tell that the vertex, remember the form calls for a negative. It says positive 1. That must mean minus or negative a negative 1. And then negative 3. Do you see how to see the vertex in the parabolic form? If I gave this to you, f of x is equal to 5 times x minus 3 squared plus 1. Where would the vertex of this parabola be located, class? Not negative 3, 1. The form already calls for a negative. So negative what? 3. Negative is already accounted for in the form. It's a 3 and a 1. Does that make sense? If this said positive 3, the form calls for a negative. So this must be the same as negative, a negative 3. Now it would be a negative. So basically think whatever the sign is right here, change it. Whatever the sign is here, keep it, and that's your vertex. Does that make sense? If I gave you a function of x is negative 4x positive 7 squared minus 2, what would the vertex be, class? Negative 7, negative 2. This keeps its sign, and this changes its sign, if that's how you want to remember it. But that's one way to find the vertex if it's in that form. The problem is, usually, the quadratic is going to be in this form. So the question then is, how do I go from the general form to the standard parabolic form? 3 steps, write this down. Step number 1, factor a from the x squared plus x. Factor the a from the x squared and the x, the first 2 terms. In other words, we don't have to worry about pulling the a all the way out, just from the first 2 terms. Step number 2, we're going to need a binomial squared, correct? When we need a binomial squared, then we're going to need a perfect square trinomial first. So we're going to need to complete the square. Complete the square. Remember, to complete the square, you take half the b value and you square it. And you'll remember that from solving quadratic equations by completing the square. Now, a couple of things. Remember, when you complete the square, you're putting a number where a number didn't used to exist, right? So we're going to have to add a number in the parentheses. I'm going to show you what all this means in a minute, and that means we're also going to have to subtract the number out of the parentheses. We're going to add it in, we're going to subtract it out, but I want you to put an asterisk where it says subtract out. Because some things are going to get a little goofy when we do the subtracting out. Again, I'll show you this in just a moment. And then your final step is to make the binomial squared. Make the binomial squared. Now again, the purpose of this is not just to find the vertex. If all we cared about is where's the vertex, I just want to do an old-fashioned graph where I find the vertex, I get some points, I graph it. We could do that from this, right? Factor out the a, negative half b, and make your table. There's going to be a lot more you can do in the standard parabolic form in the days ahead. But for now, all we're really going to worry about is the vertex. Write this down if you would and follow along with me in your notes. F of x equals x squared plus 2x plus 8. We're going to start with an easy one. One that doesn't involve factoring the a out. But if we did factor anything out of the first 2 terms, class, it would be a 1. For sake of showing the step, let's go ahead and write the 1 and leave a little gap. So we factored out the a, it just happens to be a 1. Notice only from the first two terms. Step number 2, we're going to complete the square. We're going to take half the b value and square it. What's half of 2? Squared is 1. And I put a plus 1. But here's the deal. You can't randomly just put a plus 1, you're adding to the function, right? If you're going to add to the function, you have to also take away, right? If I walked up to Kendall and was like, you know what, Kendall? Here's $100. Word would soon spread. Mr. Nadasky gave Kendall $100. I wonder what kind of dirt Kendall has on Mr. Nadasky. But if Kendall then turned right around and gave me back the $100, people would really wonder what's going on. But I didn't really give Kendall any money, right? We're going to also put a minus 1. Notice we're adding in the parentheses and we're subtracting outside the parentheses. Nothing's changing. In an equation, when we solve by completing the square, remember, we did the same thing on both sides. Well, here there's only one side of the equal sign we're working on. It's a function. Everything's on the right. So we're going to add 1 and subtract 1. And then finally, we're going to make a binomial squared. We're going to turn this PST I completed, completing the square, turn it into a binomial squared. What's the binomial? And we're going to simplify the mess going on at the end. So where is the vertex of this quadratic? -1, 7. There we go. Again, there are other things that we'll talk about later as far as graphing this thing, but for now, that's as far as we're going to go. Let me show one more, and then I'll have you, I'll take some questions. Write this one down if you would, please. F of x equals 3x squared, -6x, +7. Nice thing is, I don't have to pull a 3 out of everything, just out of the first two terms. What do I get when I pull a 3 out of just the first two terms, Genesis?
3 x squared minus,
I'm going to leave myself a little bit more room than that. Leave a little gap, and then put your +7. So we're just pulling a 3 out of the first two terms. We don't have to worry about the 7. We just leave the 7, which is kind of nice. Cuts down on our factoring. What goes in the gap? Well, we complete the square. We half and square. Those steps should sound familiar. Class, stay with me. Half and square. Again, half and square. What's half? 1. Square it. 1. Nice thing about half and square is you don't even have to worry about negative or positive because you're squaring anyway, right? So half is 1, you get 1. Or if you're more accurate, say -1. So just get 1 when you square. But here's the only thing. I'm not going to put a -1 out here because it's not really a 1. It just looks like a 1. It's in disguise. What is the actual value of that number right there, class? Its value is a 3 because of the 3 that was factored out. In the previous problem, there was a 1 out here, right? So whatever you saw is really what you got. It was genuine. Now it's like a politician. It says 1, but it's really 3. And so what do I have to put outside here to offset the addition of 3? A -3. Throw a politician outside. It's cold. I'm just kidding. I'm not actually advocating violence against politicians, for the record. Also not saying it's a bad thing, but anyway. Brandon's like, I was going to be a politician. All right.
Let's throw them out.
All right. We tried that already, remember?
Oh, yeah. Let's try.
All right, anyway. So, we put our +1, it's really a 3, and so we put -3. All right, now we make a binomial square. We keep our f of x is equal to 3, and I turn this PST class into a binomial squared. What's the binomial class? X minus 1. And then we also combine at the end to get a nice easy +4. So, what's the vertex of this parabola? +1, +4, or just 1, 4. And there we go. Questions on that? Take a look at number 31 on page 209. page 209. Put copy number 31 down on your own paper. F of x is equal to negative 2x squared, negative 12x, positive 2. If I want to put this from the general form, like it is now, into the parabolic form, which it ain't yet, but it's going to be, what do I need to do first? Abby?
Take out the negative 2 factored out.
From the...
X squared and x.
Good, just from the first two terms. Pull out that negative 2. And what does it leave us with in the parentheses?
X squared plus 6x.
I'm going to leave a little bit of room in those parentheses, and after the parentheses are all said and done, plus the 2 still. Now what do I need to do? Audrey?
Half and square.
Half and square. So what number do I write inside the parenthesis?
A negative 3.
Oh. Half and square?
Half and square. No.
9.
Okay.
I'm going to put a 9 right here. But it only looks like a 9 Genesis. It's not really a 9. What is it really? Oh, careful. Big distribution, multiplication. Negative times positive? It's a negative 18. Y'all see that? So by writing a plus 9 right here, I really put a negative 18. And if I put a negative 18, I got to balance that class with a positive 18. Does that make sense? You offset whatever you do inside by also doing it outside. So then, I now have a perfect square trinomial. That's happy. Kendall, what does it become?
X squared plus...
It says x squared plus 6x plus 9. That's a PST. I want to make a binomial squared out of it.
X squared plus 3. No, x plus 3.
X plus 3 quantity squared. There we go. 14 tries the charm, I always say. All right, we'll also keep the negative 2, right? That was the coefficient. And I'll combine these numbers here, Maddie, to get 20. All right, so what is the vertex of the parabola here, Brandon?
Negative 320.
Negative 3, 20. And aren't you glad you don't have to graph that? All right, questions on this? At your seats, I want you to do 27 and 29. 27 and 29. Convert into the standard parabolic form. It's in the general form, put it in the standard parabolic form. Most unusual handprint. Not this. Like Kendall? Wow, the good old days. I have to say, few things are cooler than when you have kids of your own listening to them like at 5 and 6 years old reading. It's like, that's pretty cool. It's a little painful to listen to. You know, if you want to actually hear how the story goes, because it's very slow. But it's like, hey, my kid can read. This is cool. I don't have to read everything to them. So, downside is now they can read billboards on the side of the road. In this day and age, that's not always a good thing. Just doing 27 and 29, several people finishing up. On number 27, class, don't really need to factor anything, so we could just group the x squared, positive 2x, and stick the negative 1 on the outside. What goes in the gap, class? Positive 1. And it really is a positive 1, isn't it? So what do I put outside? Negative 1 to offset it. So I end up getting a binomial squared, class. And then after it I get, so what is the vertex of this parabola, class? Negative 1, negative 2. Change the sign, keep the sign. How many had, well, negative 1, negative 2 is the vertex on number 27. Questions?
I didn't know I was supposed to find the vertex.
Yeah, it's okay. You got that?
Yeah.
Good. All right, number 29. We had f of x is equal to 2x squared, negative 8x, positive 9. This time, what do I have to do first, Michael?
Factor out the 2.
From just the first two terms to get?
X squared negative 4x.
Then we're going to leave the positive 9 on the outside looking in. And what goes in the gap?
4.
A 4. But it's not really a 4. It's really
8.
an 8. So what do I put afterward?
Another negative 8.
A negative 8 to offset the positive 8 that's right there. We're going to keep the 2. Going to make a binomial squared. So what goes in the gap, or goes in the parentheses now, class, for our binomial squared?
X minus 2.
X minus 2. And then after it, I just put
1.
plus 1. So even if we didn't find the vertex, what is the vertex, class?
2, 1.
2, 1. How many had that for number 29? All right, do 28, 30, 32. 28, 30, 32. Glad I don't have to graph this one. Or that one. Three for three. As you finish, check your answers. Right, any questions at all on 28, 30, or 32? Do you feel like you can work either form? And if you feel like this is faster than the other way of finding the vertex, even if it's not, it's what we're going to have to do with a lot of our lessons moving forward. I'm just curious if any of you thought it was faster. But there's a lot we can take away from this standard parabolic form of graphing. Tonight for homework, though, just want to review a little bit more like we did in the previous homework assignment, page 218. I want you to do 2 through 12, the even. Page 218 in the review, 2 through 12, the even numbered problems. Page 218, 2 through 12, the even numbered problems. And tomorrow we'll get back into the parabolic form and some things we can deduce from the equation to make it really easy to graph all kinds of parabolas. All right, have a wonderful rest of your day. And when the bell rings, you'll be dismissed.